Okay, this video will cover Unit 1, Activity 5, solving algebraic equations. Should be an S there. This is probably the most important activity in the course because solving equations is going to come up again and again in every unit we do. An algebraic equation, what is that? Well, we know algebra involves letters or variables. An equation means I've got an equal sign, which tells me that the left side and the right side are the same or are balanced. Every equation we do in this course is only going to have one variable, so either x's or p's or m's or whatever it happens to be. We're only going to see one type of letter in a given equation. And our job is to find out what that variable represents. So in the end of each of these questions, I want to know, well, okay, what is x? So you may have learned how to do this in grade 8 in the following way. I want to have x by itself, so I need to get rid of the plus 3 on the left side. To get rid of something, I need to do the opposite. What's the opposite of plus 3? It's minus 3. But to keep the two sides balanced, I have to do the same on both sides. So I need to subtract 3 from the right side as well. Well, what is plus 3 minus 3? Well, that just equals 0 or nothing. So I only have x on the left side, and I have 5 minus 3 on the right side, which is 2. So that works. That might be the way you've learned in grade 8. Another way that can be helpful to think of equations, if I ever want to move something across the equal sign to the other side, I just need to do the opposite. So if I want to take plus 3 to this side, which I do because I want x by itself, I just do the opposite. What's the opposite of plus 3? Well, it's going to be subtract 3, so x equals 2. And you might be able to do that step in your head. I'm subtracting 3 when I move this over, so it disappears on the left. And then 5 minus 3 is 2. So any of these three solutions would be acceptable to solve this problem. One thing I do want to talk about is how can we check our answers? Well, what's actually really nice about algebra is that before I leave a question, I can always be positive that I'm correct by doing a left side, right side check, which is really nice when you're doing a quiz or a test to make sure that you're correct. And the way we do a left side, right side check is I split the original question given to me into two expressions. So my initial left side was x plus 3. My initial right side was 5. And what I do is I'm going to substitute what I think the answer is in for everywhere I see x. So I thought that x was 2. So I'm going to substitute 2 for x. And then everything else will stay the same. Obviously, 2 plus 3 is 5. So my left side equals my right side, and I'm positive that I'm correct. If your left side doesn't equal your right side, then you must have made a mistake either solving the equation or doing your check. We call this a one-step algebra equation because I only needed to do one thing to isolate for x. In this class, we'll also do lots of multi-step algebra equations. And we're always going to do the reverse of bed math because we're kind of unraveling. So again, I want to know what is m. I want to get m by itself. So my first step is to move the plus 2 to the other side. And again, when it moves to the other side of the equation, the plus 2 becomes a minus 2. I always have to do the opposite. So I've got 3 multiplied by m equals 18. I want to get rid of this 3. It's being multiplied. The opposite of multiply is division. So I can do 18 divided by 3. So m is equal to 6. In general, we want to have one equal sign on each step and kind of do your best. I don't do it perfectly to line up all your equal signs. Again, normally in this math class and in all your future math classes, we write division as a fraction. But if you'd written 18 divided by 3, that's fine as well. The only thing I want to show you with this example is equations are always symmetric. And what I mean by that is it doesn't matter which side is the left side, which side is the right side. I can do the exact same thing. I want to isolate for m, get m by itself. This time m is on the right side. So I want to move everything else to the left. So again, when I move the plus 2 to the other side across the equal sign, I've got to change it to a minus 2. I do the opposite. So I have 18 equals 3m. The opposite of multiplied by 3 is divide by 3. So I have 18 divided by 3 equals m. So 6 equals m. So don't get intimidated or put off if m is on the right side. We should be very comfortable solving for variables on either side of the equal sign because it's just symmetric. There's nothing special about a left side or a right side. I'm just going to do a couple more examples together. In this next example, you notice that I now have variables, I have x's, on both sides of the equal sign. So our first step to solve is to gather all the variables or all the letters on one side and gather all the numbers on the other side. So I want variables on one side, constants on the other. Some students like to always put the variables on the left and always put the numbers on the right. That's fine, it works. You also might want to use a little bit of logic. It can be easier or simpler to think about, well, which way should I move the variables so that I have a positive group of them? Because it's usually easier to deal with positive numbers. So I'm going to move the negative x to the left side. And again, when it crosses the equal sign, it becomes the opposite. So it'll be 4x plus x. Now I've got all my variables on the left. And I want to move my number plus 13 to the right side. So plus 13, when it crosses the equal sign, becomes a subtract 13. Now I'm just collecting like terms, which we should be expert at by now. 4x plus x equals 5x. 58 subtract 13 is 45. Again, I've got 5 multiplied by x. So I need to do the opposite on the other side. 45 divided by 5 is 9. Let's do a left side, right side check to see if we're right. So I think x is 9, but let's be absolutely sure. So I'm going to split the original question into two expressions, my left side and my right side. And because there are two expressions, they'll each start with an equal sign. So I'm saying the left side is equal to 4x plus 13, and here I'm saying the right side is equal to 58 minus x. And then again, I'm going to substitute what I think the answer is. So in this case, I think my answer is 9. Everywhere I see x. And whenever we do substitution, we should always make sure to substitute in brackets, because that's going to avoid any confusion with negatives, with multiplication. So on my left side, I've got to follow bed math. 4 times 9 is 36. 36 plus 13 is 49. On my right side, I just have 58 take away 9, which is also 49. So we could say left side is equal to right side. Therefore, x equals 9. So I'm positive that I'm correct. So the left side, right side check, sometimes I'll ask for it, sometimes I won't. But it's always a good habit to get into checking to prove to yourself that you've solved the equation correctly. The last few examples are what to do with fractions. When we see fractions in algebra equations, remember that fractions are just another way of writing division. So this is really saying x divided by 5 equals 11. What's the opposite of divide? Well, it's multiply. So to move the divide 5 to the other side, it needs to become 11 multiplied by 5. So x is 55. And if I do a left side, right side check just quickly, on my right side I had 11. On my left side I had x over 5. And I think x is 55. And sure enough, 55 divided by 5 is 11. So I know that I'm correct. If I've got multiple fractions in the problem, especially when they have different denominators, it's often easiest to get rid of all the fractions before we do too much solving. So let me just start this problem off. Again, I want to move all the variables to one side. So I'm going to move that 1/6p to the left side, and I've still got -2 on the right side. Now, instead of doing fraction, addition, or subtraction, what I'm going to do is to clear all the denominators, I can multiply everything in my equation by the lowest common denominator. So that will get rid of all my fractions at once. I need to make sure that I'm multiplying by everything so that my equation stays balanced. What's the lowest common multiple of 6 and 8? So we're thinking of the lowest number that can be divided by both 6 and 8. So it's 24. So I'm going to I'm going to multiply all three terms by 24. So I've got 3 times 24, 72 over 8p. I've got 1 times 24, so that's going to be 24 over 6p. And I've got -2 times 24, which would be -48. And now I can simplify. 72 divided by 8 is, so I've got 9p, 24 divided by 6 is 4, so I've got 4p equals negative 48. So again, I'm going to collect my terms. So I've got 5p equals negative 48. And again, I've got multiplication on the left side. So I'm going to do division on the other side. So my final answer is p equals negative 48 over 5. It's fine to leave the answer as a fraction. This is already in lowest terms. Or if we wanted to, we could also punch this into our calculator, and we could have a decimal negative 9.6. I prefer the fraction answer, especially if it's not a terminating fraction. Like if it always repeats, it's cleaner to leave it in fractional form, but there's nothing wrong with a decimal as well. So I think the shortcut that I've gone over here is to get rid of the fractions in just a couple of steps. I recommend always multiplying by the lowest common denominator. Here, I'll just do one more example of a similar problem. 4, 3, and 2. They are all factors of 12, so 12 is the LCM. So I'm going to multiply all 3 terms by 12. I can't multiply only 1 by 12 because that would unbalance my equation. And I'm just going to do this in one step here. So I've got x over 4 times 12. So it's going to be 12x over 4, which is just 3x. 12 divided by 4 is 3. Minus 1 times 12 is 12 over 3 is 4. And then I've got 3 times 12 is 36. Divided by 2 is 18. So if I multiply everything by the lowest common multiple, in one step, I've eliminated all of my fractions. Now I want to isolate for x, so I should move the negative 4 to the other side. And again, as it crosses the equal sign, it becomes a plus 4. So I have 3x equals 22. And to get x by itself, I need to move the 3 over. So it becomes x equals 22 divided by 3. And again, I'd much rather leave it in this fractional form than have to divide and have a decimal that goes on forever. So that would be my final answer when I'm dealing with fractions. So that's just some quick examples of how to solve algebraic equations. You've got lots of homework problems to work through. And please send me an email if you have any questions.